Just a quick reminder of this particular sheet. If you didn't take a photo for your records, you can do so now. Now we're transitioning from irregular perimeters to irregular areas, some of which will be regular, but some of which will be irregular. Let's start with our friend, the circle. There's two ways that we could find circumference or area. One is in terms of pi, and the other one is using 3.1416, or sometimes they just do 3.14 for pi. Okay, so I will do the one on the left, you'll do the one on the right. Looking at the one on the left, this time through an area lens, area is pi r squared. Apple pies are 2. So the radius is 5, so I want to substitute in and square that 5. 5 squared is 25. And if I said to you, what is the area in terms of pi, I would just leave the answer A equals 25 pi. If I said to you, use 3.1416 or another number for pi, in this case 3.1416, I would get 78.54. Okay, and sometimes they'll tell you to round it to the nearest whole number, round it to the 10th, round it to the 100th, and so on and so forth. So that's an example of how you can use it. Again, formula for area is A equals pi r squared. Do pi times the 5 squared. And then how do they want the answer? Do they want it in terms of pi, or do they want it as a decimal? Whichever way they want it is the way you give it to them. Okay, next up, give it a shot. Okay. Working here, I will get that area is pi r squared. So that would be pi times the radius squared. And the tricky part here is the radius is not 4.3. The radius, that 4.3 is the diameter. And you have to recognize that you have to half that diameter and get it to 2.15 squared. Then you square the 2.15 and I get 4.6225 pi, which is, if I expressed my answer in terms of pi, the answer. Or if I go to a decimal, I can get 14.522046, or wherever they tell you to round it off to, okay? All right, so now we're going to do some irregular figures. And we're looking to do the area here. The area, of course, is 1/2 the base times the height if you're doing the area of a triangle, and if you're doing the area of a rectangle, it's going to be the base times height. So let's have you try the first one. Go ahead. Okay, so I like to drop this little line across here so that you can clearly see the rectangle from the triangle. So the area of the rectangle part is going to be 14 times 7, which is 98, in this case, square inches. But what about the triangle part? Well, that's going to be 1/2, and then 7 is going to be this length here. Now, how do I know that's going to be 7? I thought maybe I'd have to use the Pythagorean theorem, but no, because this is a rectangle, and if the right side is 7, the left side is 7, and 14 minus the 7 leaves 7 for the top. So that's 7, and the other length here is 14. So 1/2 of 7 times 14 is 14, not 49. So let me go correct this again. All right, so 1/2 of 7 times 14, oh, it is 49. Stupid me. It the right way. Okay, 1/2 of 7 times 14. So I'm going to do the 1/2 to the 14. That gets me 7, and 7 times 7 is 49. You could put it in on the calculator. Anyway, you look at it, the total area is 98 plus 49, which is 147 square inches. Now you look at the next figure. What two figures do you see in this irregular figure? Well, I see a half a circle, and I also see a rectangle. And I think I might have made a mistake on the circle here on the two of these put together. So let's find out. First, you do it, and then I'll show you the answers. But I think I made 2 mistakes. Go ahead. Okay, so, yep, I definitely made 2 mistakes. All right, so let me go to the end show here. I used to get very, very hung up on never being wrong. But then at some point in your life, you realize that This idea of being perfect, it's a facade, it's false, and it's never going to happen. So you do the best you can, and you realize that you're human and you're fallible. So in this case, I had forgotten to divide the circle by 2. So I'm going to do that right now and make a correction. Okay, and I also forgot the same thing here. Okay, and now let's get back. See how quick and easy it is to learn from and correct your mistakes. Okay, so we were just talking about this center figure, and what we said is, look, the area of the square, that's really easy. It's 18 times 18, which is 324 square inches. And the circle is not hard either. It's area equals pi r squared, which is pi times 9 squared, which is 81 pi, which gets you 254.47. But what I forgot to do is this is only a half a circle. It's not a whole circle. So I have to divide that by 2. And that gives me 127.235. Then I go and I add the area of the square, which is my 324, and the area of the circle, which is 127.235. Add them up, and it gives me a total area of 451.235 square inches. Now, something very similar is going to need to be done on number 3. So go ahead, stop and start, and we'll go over number 3. Okay, so doing the area of the rectangle, it's going to be 15 times 20, which is 300. Now we're going to attack the circle. Area is pi r squared. The radius is 6. No problem. 36 pi. Looking good. That's 113.1. But you have to remember, it's only half a circle here. So 113.1 divided by the 2 gives me 56.55 square inches. Adding that to the 300 is 356.55 square inches. Any questions? Preguntas? Good. Let's go on to the next question. We want to find the area in black, which makes this now a circle inside of a square. How would we do that? Well, this is the first time we've done something a little different here. So I wanted to take you through this without doing it step by step. First, we calculate the area of the square, about as easy as it gets. Since the radius of this circle is 5, the diameter, which is exactly equal to the side of the square, is 10. So the area of the square is 10 squared, which is 100. By the way, that's why we use the term square when we multiply something by itself. Because in finding the area of a square, it will always be the number times itself, hence the term squared. Okay, next, area of a circle. Area of a circle is going to be pi times the square of the radius, right? Apple pi is R2. So that's pi times 5 squared, which is 25 pi, which is 78.54 square centimeters. Now I take that and I subtract it from the 100 and I get 21.46 square centimeters. So in this case, because I wanted the black, which was part of this big outside figure, I actually subtracted off the inside figure. Now we're going back to a diagram like we had before, and this time we're not trying to find some shaded area on the outside of the figure, we're just finding the area on the inside of the figure. So go ahead. All right, so the first thing we have here is the rectangle in the middle, and if I find that area, it's going to be 60 times 25, which is 1,500 square inches. But that's not the whole figure, that's just the piece in the middle. Now I have to worry about the circle. And the circle, how do you know that? Well, first off, the circle's formula is pi r squared, right? Apple pi is R2. But how do you know this radius is 12.5? Well, the radius of the circle going out this way, all radii in a circle are equal, like spokes on a bike. So this radius going up is going to be the same. But if 25 is the distance from top to bottom, then the radius has to be half of that, or 12.5. Squaring 12.5, I get 156.25 pi. And then that, if I convert to a decimal, is 490.875. And if I want to find the total area, and I don't need to half it this time because I have both halves of the circle here. Okay, so I add those two totals up and I get 1990.875 square inches. Okay, we got one more to go over here. And this is one of those subtract guys because I want the black shaded area that's in between. Go ahead, find that area that's shaded in black. So what I see here is, first, it's a big square. So the first thing I want to do is find the area of that square. And the length of one side is 4 because I have 1 centimeter, 2 centimeters, that's 3, and another one makes 4. So that gives me 4 centimeters squared, which is 16 square centimeters. Good. Now, what's the area of the circle? Well, we kind of have 2 circles here. One circle is the circle made up of all 4 parts of the 4 corners. Each of them is a quarter of a circle. So that's pi r squared, and in each of those cases, the radius is 1. So the area of that circle is pi times 1 squared, which is 1 pi, which is 3.1416. But there's also a circle in the middle, and I got to find that area. That one is pi times 2 squared, which is 4 pi, right? Because 2 squared is 4. And if I substitute in 3.14164 pi, I get 12.5664 centimeters squared. Now, the total circle area is these second and third lines added up. And when I add those, I get 15.708 square centimeters. And then, to find the black shaded area, I have to subtract that from the total area of the square. See, the white parts are the only parts that are not shaded. So if I subtract those from the total area of the square, 16 minus 15.708, I get 0.292 centimeters squared. And those are some good examples of areas of irregular figures.